In the last lecture, we had studied about the Gay-Lussac's law of gaseous volumes. We have started discussing about the statements and we have started with one example. So let's see some more easy examples of these law. So the next example can be hydrogen gas reacts with chlorine gas to form HCl gas, okay, hydrogen chloride gas. This is not hydrochloric acid, okay, this is hydrogen chloride in gaseous form. Hydrochloric acid is in liquid form. Now, if we equate, so we need 2 HCl to match H2 and Cl2, okay. So, this is the equation. So, the coefficient of hydrogen is 1. So, we can say hydrogen is present in one volume. Coefficient of chlorine is also 1. So, 1 volume of chlorine. And the coefficient of HCl is 2. So, 2 volumes of HCl. So, the ratio is 1:1:2. Now, let's say we have taken 10 ml of hydrogen in this reaction. So, 10 ml of hydrogen will react with 10 ml of chlorine because 1 volume and 1 volume. So, 10 ml of hydrogen will react with 10 ml of chlorine and it will form 2 volumes of HCl, that is 20 ml of HCl will be formed. Now, let's see another example. Nitrogen gas plus hydrogen gas gives ammonia gas. Now, if we balance this equation, we have N2 here, so we need 2 nitrogen. So, when we put 2, how many hydrogens are there? 6 hydrogen. So, we need to put 3 here. So, 6 hydrogen is equated. So, now this reaction is balanced. Now, let's see. The volume, the coefficient of nitrogen is 1. So, we can say that in this reaction, 1 volume of nitrogen is taken. Coefficient of hydrogen is 3. So, 3 volumes of hydrogen. Coefficient of ammonia is 2. That is, 2 volumes of ammonia are formed. Let's say if we take 5 ml of nitrogen. So, 5 ml of nitrogen, that is 1 volume, will react with 3 volumes of hydrogen. So, the volume of hydrogen will be 15 ml and they will form 2 volumes of ammonia, that is 10 ml of ammonia is formed. Another last example is, let's say CO plus half O2 gives CO2. So, now it will come as 2CO plus O2 gives 2CO2. So, 2 volumes of carbon monoxide reacts with 1 volume of oxygen to give 2 volumes of carbon dioxide. So, 20 ml of carbon monoxide reacts with 10 ml of oxygen to give 20 ml of carbon dioxide, okay. So, these were the examples of Gay-Lussac's law of gaseous volumes. Now, let's do some practice problems, then we will move on to the next law. So, the first question is, the equation for the combustion of acetylene C2H2 is okay. So this is the equation for the combustion of acetylene. Now the question is, what volumes in liter of oxygen is needed to react with 15 liters of acetylene if both gaseous volumes are determined at same temperature and pressure. Okay. What volumes in liter of oxygen is needed to react with 15 liters of acetylene if both gaseous volumes are determined at the same temperature and pressure? So, in this reaction, if we write the reaction again in a fresh way, okay. So, 2 volumes of acetylene reacts with 5 volume of oxygen to give 4 volumes of carbon dioxide and 2 volumes of water. Okay. So, here we are again assuming that volumes are proportional to or multiples of the coefficients. Okay. So, what is said that what volumes of oxygen is needed to react with 15 liters of acetylene. Okay. So, the volume required in this reaction by oxygen, that is the volume of oxygen needed, is equal to 5 volume, okay, and volume of acetylene needed is equal to 2 volume. So, the volume of acetylene is given here. This is 15.0 liters. So, 2 volume is equal to 15.0 liter. So, V is equal to 15.0 liters divided by 2, which comes as 7.5 liters. Okay. So, this is the value of V. It can be said that we are taking V as a common factor of the volumes of all of these gases present here. Okay, now we have to mention that all these are gases. Okay, so V is the common factor, which is 7.5 liters. Now, volume of oxygen needed is 5V. So, volume of oxygen is equal to 5 into 7.5 liters, which comes as 37.5 liters. So, this is the volume of oxygen needed to react with 15 liters of acetylene. Okay. Now, the next part of this question is, what volume in liter of carbon dioxide can be formed from 2.5 liters of acetylene and an excess of oxygen if both volumes are measured at same temperature and pressure. Okay, what volume in liter of carbon dioxide can be formed from 2.5 liters of acetylene and an excess of oxygen if both volumes are measured at same temperature and pressure. So the volume of oxygen is not given here, but the volume of acetylene is given. So what do we know? That the volume of acetylene is 2V. So again 2V is equal to 2.5 liters or V is equal to 1.25 liters. This is the common factor of volume. Okay, so volume of carbon dioxide is what we have to find, right? What volume of carbon dioxide is formed? So volume of carbon dioxide is 4V. Okay, so volume of CO2 is equal to 4 into V is this 1.25 liter, 4 into 1.25 liter, which comes as 5 liters. So 5 liters of carbon dioxide is produced by this reaction. Okay, so now we have another question. So there is one next question on Gay-Lussac's law. This is 40 ml of methane is mixed with 100 ml of pure oxygen at the same temperature and pressure. The mixture is then ignited. Okay. Calculate the composition of the resulting mixture at same temperature and pressure. Okay, so this is a reaction of combustion of methane. Okay, methane is mixed with pure oxygen, so basically combustion of methane is what we are talking about. So the reaction of this question is methane, which is gas, plus 2 oxygen, again gas, gives CO2 gaseous plus 2H2O liquid. Here water is not in the vapor form, it is liberated in the form of liquid water. Okay, so now If we talk about the coefficients, then we can say that the coefficient of methane is 1. So 1 volume of methane mixes with 2 volumes of oxygen to form 1 volume of CO2. Now, can we say that 2 volumes of water is being formed? No, this is wrong. Okay, since water is liberated in the form of liquid and Gay-Lussac's law is applicable only for gases, so we cannot calculate water here. Okay. Gay-Lussac's law is applicable only for gases. Okay, so we cannot consider liquid water here. So what is the question? Calculate the composition of the resulting mixture. Fine. So let's say 40 ml of methane is mixed with 100 ml of pure oxygen. Now 40 ml of methane, that is 1 volume, is equal to 40 ml. So by this equation, 1 volume of methane should mix with 2 volumes of oxygen. Now if 1 volume is equal to 40 ml, then 2 volumes will be equal to 2 into 40, that is 80 ml. Okay. So in this reaction, 80 ml of oxygen will participate. But total volume of oxygen is 100 ml, right? So 80 ml of oxygen will be consumed from 100 ml. So volume of oxygen left is 100 ml minus 80 ml, that is 20 ml. 20 ml of O2 remains unreacted. Okay. And what will be the volume of methane left? Since 40 ml of methane and total is being consumed, so volume of methane left will be 0. Okay. Now the product, that is volume of CO2 formed. Carbon dioxide formed is 1 volume. So 40 ml of carbon dioxide is formed. So the resulting mixture contains 40 ml. Okay. Resulting mixture contains 40 ml of CO2 and 20 ml of O2. So we have completed the Gay-Lussac's law of gaseous volumes. In the next lecture, we will study about Avogadro's law and Dalton's atomic theory. Thank you.